What's up everyone and welcome back to my channel. We're back with day 3 of Advent of Code and we're just gonna hop right in and I'm going to open my code editor and the web browser and let's get started. Alright, and we are back with binary diagnostics. So for this one, as always, I'm gonna take a couple of minutes to read through the problem and then come back and let y'all know how I found it and hopefully our next steps that we could take to solving it. Alright, so after taking a look at this, I have a couple ideas. So overall, it looks like the problem is telling us to loop through a given list of binary numbers, and there's two numbers we need to keep track of. So there's a gamma rate and then there's an epsilon rate. So the gamma rate is if we loop through these numbers, but like at each index, it's the most common bit in that position. So our gamma rate would be, for example, 10110 because the first most common bit is 1, then over in this position is 0, then 1, and then 1, and then 0. And then the epsilon rate is basically the opposite. So the least common bit in each position, which would just be this flipped, essentially. And then the next thing we need to do is that once we get both of those binary versions of the number, we need to convert them into actual ints, and then we need to make sure that when we multiply them, we get a value, and that's the value, that's the answer. So let's go ahead and do that. Okay, so I have the sample here, and let's just go ahead and read the sample to start with. Okay, input equals input file. This is expected to give us 198. This is after we multiply everything. So first things first, we are splitting everything. Yes, so what we're gonna do is we're gonna initialize. Step 1, initialize. We're just gonna count them as strings for now. So my hope is to build up a string of like 1s and 0s for the epsilon and then the gamma rate. And then at the end, convert them to actual numbers and then multiply them. For gamma and epsilon to loop through each index, count for 1s and 0s at each index, add most common to gamma string, these to epsilon, convert gamma and epsilon to actual numbers, and then multiply them together for power consumption is what that value is supposed to give us, the power consumption of the submarine. So let's go and do that. Gamma equals this, epsilon equals this. Look through each index. So for so it looks like each of these binary numbers have the same length, so I'm just gonna get the length of the first one and we're gonna go through that. Of the first index in parsed input, so the first, so in that, so yeah, we're just going to loop through each index in the length of the first input because they're all the same, and we want to get counts for 1s and 0s, so we want to initialize our counts first. So for this, I'm thinking we could use a dictionary, then at the end we could just get the max value and the min value. So count dict equals this, and then we're going to do the key at 1 is 0, and key at, oh wait, sorry, let's do 0 first just to make things easier. 0 is 0. Okay. Okay, so at this point we have our count initialized. So now we want to go through I for each of these, for each of the parsed inputs. So we need another for loop. Entry in range input. So count dict at entry at I plus equals 1. So basically what this means is that at each entry, for each of these entries, at the current index, increment 0 or 1 based on like what the current index is of the entry we're on. Do that, and then we get back to out here. So this is just getting the counts at each index. So now we need to, after we loop through all of the entries, we want to get the most common, least common. So gamma is going to be max. So here we're going to get the max value for count dict, and it's going to be count dict dot get. This gets the key with the max value of count dict. Let's rename these two bit counts just so it's a bit clearer. All right, and then epsilon is going to be the opposite, so it's going to be this, but min, and this needs to be epsilon. So that should work. Let's also see what we're doing. So oh, I think we're missing something here. So we need to state what the key is. So key is that. Does that help us? There we go. Okay, so we get what we expect. That's good. All right, so now we want to convert these to actual numbers. So what we're going to do here is we're going to say gamma is the int version of gamma, and we can also specify a base. So we know this is going to be base 2. So let's do that, and then we're also going to have epsilon equals int epsilon base 2 because it is in binary. So let's see what these give us. Cool, so they give us the right number. So now we just need to multiply them together. So return gamma times epsilon. And print answer. 198, perfect. That's exactly what we expect. So hypothetically, we should just be able to okay, so that is quite a large number. Let's bring this over here and put this in. Nice. All right, 1 gold star, closer to finding the sleigh. Part 2. All right, so for part 2, again, we'll come back in a couple minutes. This problem's more difficult, but kind of similar. So the idea is that those gamma and epsilon values that we were getting by essentially counting the number of bits and then keeping gamma with the most common bit and epsilon with the lowest. Now we actually want to filter out those that don't have the bits that meet the criteria. So for example, for the gamma value, essentially how we get it is that we find the most common bit in each position, and then the numbers that don't have them, that most common bit in that position, we filter them out. And then by the end, we should only have one value. And then the epsilon value, which is now the CO2 scrubber rating, is the opposite. So same idea, we're tracking the same things, but we're actually acting on it now where we filter out stuff as well. So let's pop that over here. So we can probably reuse most of this. Let's change this back to sample. Sample is going to give us, same thing, we multiply it together at the end. So this gives us 230. So instead of keeping track of these now, we don't do this. Okay, so at this point, we have the number of, we have the counts. So I think we need to make 2 copies of the input. So we need the oxygen generator rating, CO2 scrubber rating, CO2 scrub rating. Okay. Oxygen generator input, filter out most okay, so less common bits, if that makes sense. At this point we want to go back through them. Bit equals filter. Oh, sorry, it equals max. It counts key equals counts.get. filter. Sorry, we take in an entry, and this is going to, we want to make sure that the entry at I equals highest bit, and we're going to pass in oxygen. So at the end, oh, but they might finish sooner. Like, we might get through these, the oxygen generator rating sooner, depending on how many things we filter out. So we want to do it again afterwards. So at the end, let's just print oxygen. We want to turn this into a list afterwards as well. Okay, that makes sense. Is that expected? Hold on. Okay, the last number is off. Okay, and the reason for that is if these are equal. Yeah, so if these are equals, we wanted to keep the 1. We might just be better off keeping actual counts then. 0 count 1 equals 0. So this is going to be highest bit is 1 if 1 count 1 is greater than or equal to count 0 else 0. Oh, but we want them as strings. That might correct that last number. Alright, bit count. Okay, now we need to do this manually. We can go back here and use a match case, actually. So entry at I, so we can match entry at I. Match entry at I. Case 1, case 0. Case 0. This goes 1, case 1. There's a better way to do to do like essentially this, let me know, because we can't use a dictionary anymore, but I might be wrong about that. There we go, that's the value we expect. So now we need to do the same thing but for CO2 scrubbing. So this entire thing can be a helper function. But then we'd have special cases for like this. It's fine, let's just repeat it. But in a programming solution, I would abstract this out into a helper function and add like flags and stuff, because all of this logic is the same. It's literally just this, and this would be like lowest bit instead. But for now, let's just do it again. CO2 scrub rating, and so this is going to be 0 if count 0 is greater than count 1 is less than. Otherwise, we're going to do 1. It's just kind of the opposite. And this is going to be lowest bit. And we want to print. What's up? Oh. Indent that. Okay, yeah. So I just realized the problem as I was doing this. So we only want to do this while this is greater than 1. The length of this is greater than 1. Thought about this and figured out how we can fix this. So what we can do is we can add a check at the end here. If the length of this is 1, we just break out of the for loop. And we can do the same here. Okay, that didn't fix it. Oh my goodness, this was not indented. There we go. So I'm just gonna keep this here so that we stop when we get to 1 position, which is what the requirements ask for. Okay, so we get these 2 values, and now what we should be able to do, so is we convert them to normal numbers, so same thing as before. Dot join CO2 at this CO2 base of 2. We want to return O2 times CO2. 230, is that right? Yep, perfect. Input. And this should give us a number. All right. All right, we did it. We got another gold star, and we are closer to finding the slay keys yet again. So thank you everyone for joining me again on this channel to complete the Advent of Code problems, and we will be back soon for day 4. See you soon, friends.